Hello everyone, I'm Jaron and I'm the treasurer of the Los Rios ACM branch. I'm one of the organizers of our hackathon, City Hacks, and I'm running a game development workshop today in Unity. I'm going to go briefly over basic concepts in the Unity editor in my presentation and then take further questions at the end to make sure to cover as much material as possible.
Hello, my name is Gabriel and I am one of the participating officers of the club as well. I will be sharing both more technical details and graphical examples of different sections of Unity alongside the Unity editor stream of Jaron's.
Okay, we're going to jump quickly over into explaining how to download Unity. So the first thing we do is we go to the Unity website, and then you follow the download steps there. From there, you'll be prompted on how to download it, and then you can open the app, and then you have to create a Unity ID, and then everything is free to use. All the licenses in Unity are only so you can sell your game, because if you want to make more than $100,000 a year off your game, you have to pay them money. Otherwise, it's just free, and all the features are in the editor for free. So you shouldn't have to worry about money at the start. So the first thing we're going to look at in the editor is the inspector. Now, this is this window off to the right here. And this shows all the characteristics of an item. So in this case, I'm on the characteristics of the camera. I've selected the camera, and now I can see the characteristics in the window. This camera has two components. One, it has a transform component, which has its position, rotation, and scale in 3 dimensions. Because in Unity, we actually have all 2D projects are actually 3D, as we can see, like this. Now, we're going to keep that in 2D for now. This camera also has a camera component, and it has several camera settings. One of them is the background color. So in this, you can change the background color to whatever you want. So I'm going to change it to that. And now there's one other very important setting, and this is the projection mode. So orthographic will project it like this in 3D. As we can see, it squeezes everything into a rectangle extending off into infinity. But in perspective mode, this expands like this in reality. Because in reality, things get smaller in the background, but in orthographic, everything stays the same size no matter its Z position. So this is very useful for 2D games, because most of the time we're going to want to fake our perspective. So the next thing we're going to look at is another very important thing, and that is the sorting layer that things go on. So I'm going to switch this back to 2D mode. And now I'm going to drag something into the scene to create an object. So I'm going to go into my assets folder in the project window. And I'm going to drag in one of my, which is a background I drew. So I'm going to throw this in here, I'm going to zero it out, and now we have this on the background. But if I drag in another asset, which is my foreground, and then I drag in the ground, actually, wait, I already have the ground. Right now, these are sorted correctly, but let's say if I dragged in, if I delete this, and then drag it in again, we can't make this go over the other one. And how we make sure that these never go on the wrong layer is we change the sorting layer right here. Now you can go in here and add sorting layers. I have 3 right now. I have a back, mid, and front layer. But you can add more if you like. Now I'm going to go to the foreground, change it to front layer. Go to the background, change it to back layer. I'm also going to set this to a zeroed out position. Now, I'm also going to have a level object on it. Now this object, it showcases the ground that I have. And I'm going to throw this in right here. And as we can see, it's also on the mid layer. So now in the camera scene, we can see it's looking pretty nice. In 3D, it looks like this. As we can see, this is what 3D looks like. And let's go back to 2D. And now we're going to take, before we move on, we're going to take a look at this hierarchy. So that's this window on the side. This shows all the objects in the scene. Now we have the camera, of course, the level ground part, the foreground, and the background. These are all sprite objects. So if we go in here and create 2D object sprite, we can create several different sprites, and then we just change what image it is by changing the sprite. Right here, we can just drag to change the image right here. And there are other things we can add, such as particle systems, UI elements, and like audio sources and stuff, but we don't have enough time to cover all those. So we're just going to cover one very important thing, and that's a create empty. So when I create an empty, it creates a game object with nothing on it. It only has a transform component. So with this transform component, you might think, why does this have any utility? It all can do is move. It doesn't even display anything on the screen. Now, it is useful because of this. If I take this object, I can make other objects the child of this object, so that this object will now move. If I move this object, it moves the objects that it's children objects. Now, you can't do that normally. You would have to select all the objects, so it can be very useful for categorizing elements.
All right.
Now,
sorry.
Okay, continue.
Oh, yeah, so I'll interject it quickly on the objects in general. So as Jaron demonstrated, since sprite objects are primarily seen as visual elements, layering these your game objects is very important, especially when you consider what perspective is in. For example, there are games such as Bastion that are seen in a what's called a isometric perspective. So you look at it from a 3D perspective, and you look at all of the objects in a scene as if you were seeing them from a specific corner. So when you're layering your objects, it's important that they appear in the correct sequence of order. You don't want, for example, some house in your scene to be right behind what's supposed to be a cliff face, or your character to be hidden from a building when you're playing, right?
Yep, of course. And also in isometric games, all the tiles are sorted from back to front, so the tiles in the front are in front, actually physically in front of the tiles in the back, because they're all really 2D images. And when you move lower down on the Y, since the perspective never changes, you can just make the ones in the back on the back layer and the ones in the front on the front layer. So that can be very interesting. It can be a very interesting looking game when you make it isometric. Actually, Monument Valley is slightly isometric, but it's more complicated because it's actually 3D. So I think we're going to move on to talking about two very important windows, which we've already been using. One is the scene window, which is this window right here. This window shows graphically all the assets in the scene. As we can see, we can move objects around by using these controls. So this one's a move control for the scene editor. This one's to move the objects. This one can rotate the objects. And you can even rotate them in 3D, which is very cool. And you can scale the objects. Rectangular scale them, or do everything at once. And then this one's for custom tools. And now you can also change things to wireframe, so you can just see how things look. Or you could turn off these gizmos. And gizmos are essentially this camera icon, but I don't usually like to do that because I feel like that would be a fairly bad idea, because I want to see this, because otherwise I will never be able to see the camera. Now, I go to the other window right up here, and this is called the game window. Now, in this game window, you can scale in if you want, but this shows the rendered version of what the game's going to look like when you hit play. Now, there are a few settings that you might want to know, and that is VSync in the corner. This is for the game view only, not the exported exe. And then you can also change the aspect ratio by adding more. So if I change it to 100 by 500, it looks like this, but let's keep it at the other one. And now I'm going to show another one, and this one shows statistics about your game while it's running, such as the FPS, which currently is not running. So let's run it, and let's see what happens. So I'm going to play it right here. Oh, nothing happened. Isn't that strange? Well, if we look, we have 60 FPS. That's because VSync's on. If I turn VSync off, we will see our FPS goes up in the thousands. But VSync keeps capped to 60 FPS, so we don't have any screen tearing. But the reason nothing is happening is because we didn't tell anything to move. What do we want to move? You don't need anything to move yet. And this button will pause your game, but we can't even tell if it's paused yet because we haven't done anything. Now, we also want to remember that nothing we do in play mode will affect what is done outside of play mode. So if I take this and I delete this object right here, it's gone. When I unclick play, it's back. No changes are saved while you're in play mode. So the next thing we're going to do is we're going to add colliders to these objects. Well, actually, first we're going to drag in our player. So we're going to put our player right here. As we can see, it's not in the correct layer. So let's move that to our mid layer. Now I'm going to scale it down. So now we have a player right here. Actually, scale down a little bit more. Okay, so now we have a player. But when I click play, it still doesn't do anything. Now, the problem is we haven't added colliders yet. Now, we're going to want to add a capsule collider to the player because the capsule is exactly the shape of our player. So when I add this, if we zoom in and click Edit Collider, nope, not in this window. So when I click Edit Collider, we can change the scale of this collider to fit our object perfectly. Like this, just move it up. Now our object is, this is the colliding boundaries for our object, because otherwise Unity doesn't know what it is. Now, we don't only need this, we also need one for our ground element. Now, you can add a Polygon Collider, but I already have added one, and I have dragged all these polygons to fit the collider. So, just for review, we have the collider on this object and the collider on the ground object. Now, I'm going to hand it over to Gabriel to talk a little bit more about colliders before we move on.
Thanks. So you can think of colliders as scripts in of themselves tied to the game objects. What the scripts do is essentially get the distance from the object to which it's tied to from other objects, which also probably have colliders. The thing to keep in mind is when you're developing games, sometimes there are cases in which you want to make your colliders smaller than the visual size of your sprites. So some of you might be familiar with shooters, and a lot of shooters typically make their colliders smaller than the actual sprite size of the player object, so that the player is indeed able to dodge or game objects or squeeze through obstacles. Now, the other thing to keep in mind about colliders is, as Jaron is showing, especially the floor, you can see that this polygonal collider is more or less made up of just several triangles. Now, polygonal colliders can be effective, especially when you want to make your environment, the collider to which it's tied to, if you want to make it as precise as possible, so that there's no, it doesn't go over the floor or perhaps miss any corners. The only small issue is just it takes Unity more time to keep computing collisions per triangle, whereas rectangular colliders and circular colliders are generally recommended for both ease of use and faster game time to
Yeah,
to
polygon
Polygon.
colliders are most useful when you have a really complicated mesh. Because if we look at this mesh, how are we going to define this? We would have to make many box colliders, and we'd also have to make some triangle colliders to even get this to work. So because it's such a complex shape, we're going to have to spend more computation power to even compute the collisions on it. So it's probably worthwhile to use a polygon collider. But let's say if you have a player, you don't want to add a polygon collider to this because it can be defined by a capsule collider. And if it can be defined by a capsule collider, then it is more efficient to do so. And you do not want to define it as a polygon collider. So now, if we play the scene, we should expect that the player would just fall onto the platform. But nothing happens still. Now, this is for one simple reason. Unity does not have built-in physics for the colliders, unless you add a rigid body component to one of the components, or one of the game objects. Now, I'm going to add the rigid body 2D, because a rigid body is normally in 3D, and rigid body 2D is more efficient. So if I add this object, oops, I added the wrong component. Okay, so I was supposed to add a capsule collider 2D. And then let me add the rigid body. Make sure you're using 2D components, because otherwise they will conflict, because you can't use a 2D collider with a 3D object. So if I add the rigid body now when we click play, watch what happens. Oh, the object has fallen. Now, as we can see, this object is actually reacting to physics. As if I add another object, you can see they just fall over. I'm going to add a bunch of them just to showcase that Unity can handle a lot of objects without any issue, especially on a more powerful computer. So once these objects stop moving, I believe Unity makes it more efficient and doesn't even run the physics simulation anymore on them. So I think the frame rate would stabilize at this point, unless I edit one by, let's say, going into the scene editor and moving this object. As we can see, they're all dynamic and they can all move. So now I'm going to leave the game editor and see we're back to this. But the problem is, players are not just inanimate rocks. They don't fall to the ground and then roll around. Well, unless you're a firefighter. But that's besides the point. So what we need to do is have the player move. But how do we do this? Well, we are going to use scripts. Now, we don't have time in this presentation to code our own player movement script, so I'm going to use one that I typically use in my games. So this is in my assets folder and into my scripts folder, and I have a player controller script. Now this is coded in C#. And before I assign this to the object, I'm going to turn it over to Gabriel to talk a little bit about scripts in Unity.
Thank you, Joy. So, for the moment, we're disregarding which computer language it is. When you're going into game dev and you want to make your game objects move, whether by input or whether reacting to the player object, you typically want these scripts to keep consideration of variables of other objects as well as its own. Now, these game objects are typically instances, or you could say copies of what's known as a class. Now, in computer languages, classes are similar to structures in that they hold variables and functions, but these classes can also keep certain variables private so that you don't accidentally change it mid-run of your program. These scripts are also useful so that you can define a function where perhaps you go into the AI of an enemy object, and so with Unity you can simply drag the script of your own making to the different enemy objects, so you don't have to program each enemy object by hand.
Yeah. So all Unity does when you're using a script is it assigns the script to an object. Now, all this is doing is referencing the object. Unity determines which objects use which scripts, but it's all the same script. So if you have one script and you assign it to two objects, both objects are affected when you change that script. Now I'm going to very briefly look over the script because some of the stuff is important. These using things allow you to use Unity special commands. And then right here, this is basic C#. You can have public and private components here. And then the functions here, some of them are called by Unity. Like void update will be called once every single frame. And void start will be called once at the start of every frame. There are several special functions like this. And I believe void awake is one of them. I think that happens when the project is initialized at the very start. Now, to make this actually operate, I'm going to drag this script onto the player, like this. Now it's added to here. If I didn't want to do that, I could also add it like this. You can see it's right here, player controller. And now I'm going to go back to here. I'm going to change the body type to kinematic. So what kinematic will do is disable Unity's default physics. So I'm going to place it right there. And I'm going to freeze rotation around the z-axis, which means this direction. So let's play the game now. Now, let me see. I forgot to, this script in particular, this is not for anything else, but this script requires an animator component. So let me, okay, there we go. Okay, so now I can move from left to right, as we can see, and I can run around in the scene. I can even jump. And as we can see, it collides with all our walls correctly. And just like that. And then I can duplicate this. Well, actually, I don't quite want to do that because it'll glitch it out. Okay, let's disable the player controller on this script and the animator. So now I can just copy and paste this. Oops. Okay, I'm trying to make it so these objects have physics. So if I make this object have physics and then I add a few more of them, as we can see when we go into our game view, I will interact with these objects too, because they also have colliders along with the ground. So any dynamic objects can be moved, but as you can see, when I'm a kinematic one, I can't move these objects. I would have to be a dynamic object to move other objects. So I'm also going to talk about a few other things now that we've got this game running. Now, if we go into our assets folder, this is the project window. Now, this is very important because this is essentially a file browser for your entire project. You can create anything in here. You can create like 2D sprites, you can create materials, you can create scenes, and then you can import any asset you'd like. You can import packages, which are essentially just a bunch of assets. And then you can also look at objects import settings. So I'm going to go to this object, and I'm going to change this to the defaults. So I'm going to apply this. So now I'm going to disable these objects because we don't need them at the moment. And I'm going to drag this object into the scene. So when I scale up this object, let's look at this in the game view. Look how blurry that object is. That is not what we would like for pixel art. We don't want a blurry game object. Well, how do we fix it? Well, we have to go into we have to click on the object in the project folder, or the project window, and now we have to change the filter mode. So the filter mode is essentially a scaling algorithm. Bilinear will sample pixels from around the original pixel to kind of blur it out as it expands. And this will make normal images look better, but with pixel art, we don't want this. So we're going to change this to point, no filter, because it just scales up the pixels. It just takes 1 pixel to 4 pixel to 16 pixels, etc. Actually, it would be 9 pixels in between that. But then we also when we hit apply, now look how beautiful that is. And now sometimes you can also have issues with compression. So if you change this to none, you can make sure you have no issues with compression. Now our object is nice and crisp, even when we scale all the way in. This is far beyond what we should normally be able to scale into, but it still looks great. So that's how to import pixel art. Now there's also a few other windows I'd like to just breeze over, and that's one of them's the console. This will print errors and warnings when the project is running. And then there's also the animation window, which is how you animate objects. There's the profiler, which is complex, and you probably won't need it if you're making a small sized game, but if you're making a really complex game, this will help you make it more efficient, because it will tell you stuff about the runtime of the project. Now, these are not all the windows that are actually in Unity. There are actually more windows. And you can do this by going to Window, and then looking at all these extra windows. Now, several of these windows are very specific cases. You can look at the animation windows and stuff. You can mix audio. You can do sequencing. The profiler is essentially how you make your project more efficient and debug it. And then in AI, you can do some navigation. But let's go to 2D and click Sprite Editor. So let me drag this in here. Now we can see that we can edit our sprites in this. So we can change certain characteristics of it. And one of them is the pivot point. So if I go into the scene and I spin this object, it spins around the center. But in the sprite editor, we can determine where we want that to go. So I can change it to the bottom center and apply. And now, look at that. The thing now pivots. Actually, it just changed its origin point, actually. So, I forgot. It doesn't actually rotate around that point. Doesn't actually rotate around that point. It just changes the location of the object. So as we can see, this is 0, 0. And that's because this point is centered at 0, 0, not this point. So if I change this back to the center, and I hit apply, as we can see, it's back in the center. So this one can be useful if you're doing certain things. You can change other settings, and you can change the pivot unit mode, and you can also do change some other stuff for that. And then you can right click on this and close the tab if you so desire. And now there's one other thing I didn't realize how to use in Unity when I was starting out, and that was scenes. So when you open up Unity, by default, you will have one scene, and it will be called sample scene, I believe. And a scene was essentially, they're all part of your project, and you can load them in, I believe, with scripts, but it will make it so you can split your project into sections so you don't have to run it all at once. As we can see, if I click on this scene, the characteristics have changed. If you look at the hierarchy, it's different objects because it's a different scene and it's organized differently. Now, this doesn't take a lot more storage because these objects are all still the same. They're all sharing the same library of objects. They're just positioned in the scene differently. Now, I think we've covered most of everything that you need to get started very initially. So now I'm going to show these again because I think it's prettier. Okay, let's delete this one. So we have our object now. It has a rigid body, a player controller, and now our game is finished. Well, sort of. We want to export it now. How do we do that? Well, we go to File, Build Settings, and we want to make sure what platform we're exporting to. And we can click Build, which will build it as an exe to a file of our choosing, or we can click Build and Run, which will build the file and then run it directly. Those do similar things, but usually I use Build and Run because I'm usually trying to test my game out. So I'm not going to do that right now because I would have to stream another window, but that's how you can build your thing as an exe. And if you download the Mac exporter, you can export it to Mac, etc. And I think you can do it to all of these. So you can do it to iOS, PS5, WebGL, tvOS, all these things. And you can do it to Mac too, which might be included in them. I'm not 100% sure. Okay, let's see. I think we've covered everything. Okay, Gabriel, do you have any other additional thoughts you'd like to add at all before we move into the
Well,
Q&A?
this is very, very slightly tangential. Although I am not personally familiar with the sprite editor or of Unity, but if anyone's ever interested in creating their own graphics for their own games, especially 2D pixel style graphics, I personally recommend Adobe Photoshop and this program called Paint.net, as well as ProMotion NG. So the first two that I mentioned, Photoshop and Paint.net, they're really good, especially for static images. Photoshop has its own library of brushes, and I tend to use Paint.net more, just for the ease of navigation. And ProMotion is very good, especially for both creating tile maps, creating and editing animations, not just static images, and also having very, very simple scripts to make some of your animations interact with each other. But yeah, that's all.
Yeah, I actually drew this scene in Photoshop myself, and which is the program I personally use. I also have heard that GIMP can also be a good substitute for Photoshop, since Photoshop is kind of expensive, but I think you can get it for cheaper at Sac City. But I defined these brushes myself. I drew all of these brushes, except for that one. I took that one. But I drew the bush brush myself, and I just made a simple selection, and I kind of did some fancy Photoshop tricks to just make the scene pretty quickly. And I just split it into 3 layers, so I had a background, foreground, etc. I could just move it around like that. And I just composed these different layers, and I had a scene. And okay, so I think we've covered essentially everything we want to cover in this call. So does anyone have any questions about the editor? Anything they would like to know how to do? Anything that we didn't cover that they think might be useful?
I had a quick question.
Sure, what is it?
So is Unity like the most popular program software to use, or are there other softwares as well?
Okay, so Unity is the one I personally use, but Unity is definitely not the only software. It is one of the most prominent ones, but there are also other very popular engines such as Unreal Engine 4 and Unreal Engine 5. There's also Game Maker Studio. There are also some smaller ones that I can't remember the names of, but there's one that you can make games in with essentially pixel art, and you can compose it all into one image.
And then one more question: what
You can
popular
even use-
games have been made with Unity?
Oh, what? Actually, one of the ones I spoke of was made in Unity. Have you ever heard of the mobile game called Monument Valley?
I never have, but maybe you could show us like a visual or something.
Let's see. I'm not sure if I. Let's see. I might be able to show. Okay. So Monument Valley is a really cool game, and it's essentially based off of perspective. So essentially anything that looks like it's true is, even if it's geometrically not possible. So let me just this image and then throw it into Unity, and then I can show it to you guys. Okay, so sorry. I'm not sure exactly what happened.
If I can make a quick remark, I believe a lot of mobile games are made with Unity. These days, I tend to play mobile games more, and so let's see. There's this one mobile game based on Tomb Raider. I believe that was made with Unity. Um, I don't have any other specific ones in mind, but yeah, like especially since the games they start out by showing you,
Ah,
it's made with
I,
Unity.
I remember other ones that were made with Unity. I can't believe I forgot them. So popular games such as the Kerbal Space Program have been made with Unity. Also Hollow Knight and Cuphead. And there's also Ori and the Blind Forest. Um, and then like the Monument Valley games, as I said, there's Crossy Road has been made with that. Also Kerbal Space Program 2, Beat Saber, Alto's Adventure, there are a bunch of popular games that have been made like that. A lot of popular games though that are like AAA games are going to be made with their own engine by their studio, which may not even be public. So that may not be why you may not hear of something like Halo being made in an engine like this, because they have custom engines. But we can't all afford to make our own game engine. So a lot of indie games are made in these engines. And in Unity usually holds as a one step up over Unreal in 2D games. But in 3D games, Unreal is slightly better. But since I'm making 2D games, I like Unity, and it's also the one I started with, so I quite like it a lot. And I haven't found any real issues except for the fact that sometimes they do change the editor. Like if you look at some of the documenting about the editor and stuff, it gets outdated pretty fast because they change stuff about how things work. Mostly you're not going to notice it when you're in the editor, but when you're looking for old stuff and then you find something from 7 years ago, it's probably not relevant anymore. Any other questions at all?
How is Unity for VR? I've been looking into that probably. Or
Um,
AR.
I am actually not sure. I've never made a VR game in Unity, but I know it's possible because I just saw that Beat Saber was made in Unity. So you can definitely make VR games in Unity.
That's
Um,
cool.
let's see if there might be like, oh, that was AI. Yeah, I don't know. I would assume you just have to. There's probably some tutorials out there. VR is still kind of new on like the game presence, and it's still kind of coming up because a lot of people don't have a VR headset, so they have a smaller market at this point. But I'm sure that will be changing pretty soon as things become more affordable and things. But I'm not sure how to make a VR game at all yet. Maybe I will. A VR 2D game, one that just like simulates you just looking in front of at a computer. It's exactly the same as before, except you don't need the computer.
You know what like features that AI system gives of the Unity game engine?
I am not sure. Let me go check that. Let's see. This may.
Meshes and bakes kind of reminds me of certain 3D modeling terms. I'm not
Yeah,
sure
I think this
what
may
has
be
to do
more for
with.
3D models because in Unity you can bake lighting and other stuff. And I didn't know what that term meant before, but essentially what it means is you add the shadows to the texture. So the shadows they're no longer dynamic, which makes it a lot easier for the engine to run them, but you can't have dynamic shadows. That's why in a lot of games there's settings for dynamic shadows or not, and that's why a lot of people turn them off because it's too much for their computer to handle.
And also I heard about something called ray tracing. So like does Unity have that? And like what
Let me
allows
see.
you to use that?
Okay, yes, it does, essentially, and I'm not in a 3D project right now, but you can turn on ray tracing to get essentially pretty photorealistic results in Unity, just like how Unreal has it. So, Unity is essentially a direct competitor to Unreal. They're both very large companies now, And they both offer things for 2D and 3D games, although Unity is slightly better with 2D, and Unreal is slightly up there with 3D because Unreal has the lighting engine Lumen, which allows them to light really big scenes, and they also have that can't remember what it's called, but it's this really, really cool way of rendering models that allows them to have extremely high polygon counts. So essentially, in Unreal Engine 5, the program will use AI and like a really clever sorting process to only render the triangles it deems necessary. So if you're really close up, it'll render a lot of them, but in far away, it'll render far fewer. And this way you can get extremely high details while only rendering so many polygons. And that allows them to drag essentially movie assets into the game and then just hit play, and then you don't even have to worry about the polygon count. And it's just shocking, and I don't even know how it's possible. But it's this really clever system of essentially pre-sorting all the polygons and then using AI to kind of determine which ones need to be drawn. It allows them to essentially model pebbles on the ground.
If I can quickly remark, yeah. So especially since I've seen this in the Unreal 5 engine demos, so it's just a matter of seeing which objects are even able to be visible from by the player to begin with, and then it takes into account the triangles on the models that are visible, and so really at that point you're only seeing the front, from your perspective, the front of all the models on screen. And so the engine takes care of not having to render every single triangle that's not even, that's occluded, which is just hidden or not visible in the gameplay. And so, yeah, as Jaron said, with those techniques, you can compromise very little on game speed, or you could say on processing power, while also being able to, yeah.
Actually, I have an image that shows this. So let me just move it over here. I just brought it into Unity for ease of access. So if we look into this, this is a representation of all the polygons that are being rendered. If you look in here, these polygons are so small that you can't even see them. Actually, let me do that exact thing that we were talking about earlier and change it from bilinear to point no filter so we can see it without the blurs. Okay, so this is you look in this, these triangles are bigger because they're farther away and they don't need to be rendered. So they're just bigger and it's just the texture is like that. But this face is really close, so it has an incredible amount of detail. But the developers at Unreal have come up with a really clever way to make it so that to essentially determine which ones to sort extremely fast. So I believe it uses something kind of how Google's search uses it, where they categorize all the polygons, and then they can just determine by going from the previous polygon to the next one of which ones that really need to be rendered. And then they can just like add them up like this, and then they don't need to render them. So that's a really cool thing. You can get amazing, amazing results from Unreal and Unity too. So here, I'm going to import in actually one of Unreal's images right here. Amazing scenery. And if we look here, this scene, we can't see it in this scene, but you can zoom in to here, and essentially particles of dust on these eaves would be modeled. That's a little bit of an exaggeration, but essentially they're just elements that are 3D scanned from real life into the game. And we don't even need to worry about shrinking the polygon count or anything, because that's what the AI does for us. And this is not Unity, but it's still with game development, and Unreal is a very, very valid alternate to Unity. And I don't personally use it, but I would definitely use it I don't know if I can recommend one over the other for any case. For 2D, I might recommend Unity just because it's what I've done, but Unreal is also really good, as from what I've seen. And it also has a similar amount of games made in it like that.
Is that like image compression or like just?
What do you mean for the rendering thing or in
Yeah, the rendering. It's like compressing
like,
an image down.
I don't think so actually, because compressing image tries to actually it's a little bit similar because JPEG compression tries to get the image to a smaller size by removing unnecessary details. This is essentially what this does, but it has an entire polygon mesh to determine. And it's got an incredible amount of polygons. Think millions and millions and millions of polygons. You have literally maybe each rock is 1,000,000 polygons. So you have maybe even billions of polygons in your scene, and you're only rendering a choice few of them, so the scene looks good. But when you zoom into objects, you can get incredibly high detail on each object. Okay, any other questions?
It's like, what features allow you to have like a multiplayer game? I heard like you had to like do some web socketing type stuff.
I'd have to actually go research that. I've thought about making a multiplayer game, but I haven't done it yet. But I'm 100% sure you would have to do something like that, yeah. So I probably can't answer that one to any extent because I haven't really done anything with multiplayer in this, and even in other things, I haven't really done that much multiplayer. I should probably do some more. But oh, also, actually, before we leave, I just noticed that this camera right here, if we look, the camera boundaries are not at the edge of the boundaries. It's too close. So how we do this to extend the camera, we go to the camera component, we change the size to 5.4 because 5.4, their units, I believe, are 100. It's like some amount of pixels, but essentially because the screen is 1080 pixels tall, it means it's 540 times 2. So 5.4 is just the perfect value that measures up with the size of the screen. So if we look at it now, we got the whole game view in actual like 1080p, and then you can also click maximize on play to put the game in full screen. Okay. I think we're probably nearing the end of this right now. Any last questions before we end this stream? Or any last thoughts, Gabriel?
I'm not sure what else to share without needing additional context for just to as visual aids.
Okay, well, then I think we shall end the stream here. Thanks for watching. I hope you learned something about game development in Unity. Also, there are alternatives. This is just my experience in Unity.